Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 86 to 90, part 9 of our ELM EPT review questions. And this is going to focus mainly on geometry. Don't forget to visit our website at math.serve.com for access to a wide variety of tutorials ranging from algebra all the way to calculus. All right, let's take a look at problem number 86. In problem 86, it says that in the figure above, two rectangular solids meet to form the L-shaped solid. What is the volume of the solid? So if you look at your reference sheet, you have the formula for the volume of a solid provided. Okay, so let's go ahead and write that down. Formula for volume of a rectangular solid is area of the base times height, which is length times width times height. In previous tutorials, I showed you a formula. Big B times H is exactly the same thing as this. This big B times H formula applies to prisms. So a special case of that is a rectangular prism or rectangular solid, which you use length times width times height. Okay. All right, now let's look at this situation. We have a composite solid here made up of two rectangular solids. So the smart thing to do will be to divide our two shapes into two distinct rectangular solids. Okay, so how do we do it? We can divide it along this line, either downwards, or we can divide it horizontally. So let's go ahead and divide it in this orientation, downwards like that. Now what we have is we have two rectangular solids with their unique length, width, and height. Okay, so let's see. How about we label them 1 and 2 so we don't get confused? This is rectangular solid 1, and this is rectangular solid 2, just to avoid confusion. Now what I'm going to do is I'm going to list the dimensions of rectangular solid 1, and I use that to find the volume of solid 1. And then we'll list the dimensions of solid 2, use it to find the volume of solid 2, and then the sum of the volumes of the two solids will be our resulting volume. Okay, so let's start with solid 1. So for solid 1, we need the length, the width, and the height. The length is, what is the length? Let's see. This is 2 and this is 6. If the entire thing is 6 and this piece is 2, what would you have left? So let me just give you an illustration here. So this is 2 and the entire length all the way there is 6. So what's this missing piece right here? It's 6 minus 2, which is 4. Okay, so this part right here is 4. And then down here, from here to here, is 4. Okay, so the length of solid 1 is 4, the length of the base. Okay, so we have that down. And then the width, how wide is it here? Well, this side here is congruent to this side, is congruent to that side, and is also congruent to that side there. So that's 2, this is 2, this is 2, and this is 2. So what does that tell us? It tells us that the width of solid 1 is 2. Okay, it's exactly the same thing as the width for solid 2. We'll talk about that later. So the width is 2. Now, how high is solid 1? Solid 1 is 2 units high, as we can see here. So there goes our height 2. Okay, so this is the length, width, and the height. So what is the volume of solid 1? The volume of solid 1, using the formula length times width times height, is 4 times 2 times 2, which is 16. Okay, now let's take a look at solid 2. For solid 2, we need to find the length, the width, and the height. Okay, so let's find the length first. The length, that's 2 right there, so this is going to be 2 also. So the length is 2. The width, how wide is it? We know it's 2 up there, it's 2 right here. That's how wide it is at the base right here, the same as this 2. So that's 2. The width is 2. Remember, the area of the base is congruent on the top and the bottom. So if you look on the top here, This is the length of 2 and the width of 2 also. All right. And then the height, how tall is solid number 2? Solid number 2 is 10 units long. All right, so volume of solid 2 is length times width times height again, which is 2 times 2 times 10. 2 times 2 times 10 is 40. Okay? So what is the volume of the solid? So volume of the solid is simply volume of solid 1 plus volume of solid 2, which is 16 plus 40, and your final answer is 56 square units. All right, so our answer is option letter B. All right, let's take a look at problem 87. It says the area of square ABCD in the figure above is 64. What is the area of the shaded triangle AED? All right, so area of a triangle, what is the formula for area of a triangle? Area of a triangle is 1/2 base times height, right? So all we need to do is find the base of this triangle and also the height. How do we do that? Well, we're provided with a clue here, which is that the area of the square is 64. So if this is a square, that means this side is S, and this side is S also. In fact, all four sides are S's, okay? So the formula for area of a square is length times width, or S squared, since length and the width are the same. Now, since the area of this square is 64, what do we have? We have the area, which is S squared, being equal to 64. Now, can we solve this equation for S? Absolutely. Just one operation. You just root both sides, and then you have S side length is equal to 8. So this is 8, and that's 8. All four sides are 8 units long. Now, the side length of the square is the same thing as the base of the triangle. So B of the triangle is 8. What else do we need for the triangle? We need to find the height, because half base times height gives you the area. Okay, so this is the height, the perpendicular height of the triangle. So how long is this height right here? What is the height of the triangle? Well, this is a square, so the altitude of the square is constant across the entire region. So this side is congruent to this side, and it's congruent to that side, all right? So this is 8. Guess what? The height also is 8 units long. Any point from this side, from BC to AB, any perpendicular length is going to be equal to 8, all right? So we know what H is. H is 8. Now let's go ahead and find the area of a triangle, because we have all the things we need, namely the base and the height. So the area is going to be 1/2 base, which is 8, times the height, which is 8 also. All right, so if you do the calculations, you have 8 times 8 is 64. Remember, when you multiply fractions, you multiply across, okay? So we have 64 on top, 8 times 1. At the bottom, 2 times 1 times 1 is 2. 64 over 2 is 32. Okay? So our final answer is option letter E. All right, let's take a look at question number 88. It says a stack of 3 cubes of the same size has a volume of 24 cubic inches. What is the length in inches of an edge of one of the cubes? So let's see here. What is the formula for the volume of a cube? The volume of a cube is length times width times height, but they're all the same, right? So simply side to the third. S to the third is the volume of your cube, okay? So in this situation, we have 3 cubes. So we're going to be multiplying the volume of each cube by 3. Okay. So in this case, we have 3 cubes. This formula is just for the volume of 1 cube. So for 3 cubes, we have to triple on both sides of this equation, right? So the volume of 3 cubes, 3v, is equal to 3 times s to the third. Okay. Now we're told that the volume of the 3 cubes is 24. So how can we apply that here? 3 times s to the third which is the volume of 3 cubes, is equal to 64. And S is going to be the length of one side of the cube. Okay? So let's go ahead and find out what S is. It's a two-step algebraic process. You divide both sides by 3, and then you take the cube root. All right, so let's divide by 3. Divide by 3, divide by 3. And then you have S to the third. S to the third is equal to, actually the volume is not 64, the volume is 24. Sorry about that. Volume is 24. And then we're dividing that by 3. 24 over 3 is 8. And then we're going to take the cube root of both sides. Take the cube root there. Take the cube root here. And you have the side length S is equal to 2 units long. So that is the length of one edge of the cube. All right. All right, let's take a look at problem 89. It says, what is the perimeter of the figure above if all intersecting line segments meet at right angles? All right, so let's see. In order to find the perimeter is basically the distance around the entire object, right? The length, all the lengths combined. So that's what we're going to use to find the perimeter. All right, so let's go ahead and see how many sides we have here. Let's enumerate the sides. This is side 1, 2, 3, 4, 5. Let's try that again. 4, 5, 6, 7, 8. So we have 8 sides. Now the mistake that most students make when finding the perimeter of composite figures like this is they forget a side. Okay? So that's why I enumerated all my sides so I don't forget anyone when I'm adding it up. Okay, so let's see here. Now that I've enumerated all the sides, let's go ahead and find the length of every single side. Side 1 is 2x. Side 1 is congruent to side 7, so side 7 is 2x also. Okay? Side 3 and side 5 are congruent to each other, so this is x also. Side 2, 4, and 6 combined is the same thing as side 8, the same length as side 8. So since side 8 is 3x and side 2 and 6 are 2x combined, what is side 4 going to be? Side 4 is going to be side 2 and 6 minus side 8. So it's going to be 3x minus x plus x. Okay? So side 4 is going to be what? It's going to be x unit long. How do we know that? Because side 2, x, plus side 4x, plus side 6x equals what? 3x. X plus x is equal to 3x. All right? Let's see. We have all the sides. Now let's go ahead and find the perimeter. Perimeter P is going to be side 1 plus side 2 plus side 3 plus side 4 plus side 5 plus side 6 plus side 7 plus side 8. Okay, I'm just listing it out. You don't have to do this, but the reason I'm doing this is I want to make sure I don't forget anything and get the wrong answer. All right, so side 1 is, what is side 1? Side 1 is 2x. 2x plus side 2 is x, or 1x, plus side 3 is x, plus side 4 is x, plus side 5 is x, plus side 6 is x, plus side 7 is 2x, plus side 8 is 3x. Okay, so we can add this just by pairing them up. So let's do this first, these two together, and then these two, and then these two, and then these two. Okay, so 2x plus 1x is 3x, plus x plus x is 2x, plus x plus x is 2x. This goes here, plus 2x plus 2x is 5x. Okay, now let's go ahead and add it further. We're just going to combine these two, and then combine these two. And then you have 3 plus 2 is 5x, plus 2x plus 5x is 7x. 5 plus 7 is 12x. Now this problem is not that difficult, but it's very, very easy to make mistakes in your arithmetic. You see, that's why you have a lot of traps here. Just by missing one side or yeah, just by missing one side, your answer could easily become 10x, 11x, 8x, or 6x. So whenever you're finding the perimeter of a composite figure, please enumerate the sides and ensure that every single side is accounted for. So by using a formula like this, explicitly stating what the sides I'm summing up are, it makes my substitution and consequent computation accurate. All right, let's take a look at problem 9. It says, in the figure above, John's barn is 200 yards due north of his house, and his tractor is 300 yards due east of his house. How many yards must he walk to go directly from his tractor to his barn if he walks in a straight line? So whenever you have a word problem and an associated figure, you always want to make sure that your figure is accurately labeled using the information provided, okay? So let's go ahead and label the figure. All right, so what we want to label is we want to label the barn, let's see what else, the house, and the tractor. Okay, so let's go ahead and label them. We have, let's call the tractor, this is T, and then, which is the house? This looks like a house, so let's call this H, and this is the barn B. Okay, so it says, in the figure above, John's barn is 200 yards due north of his house. What is the north direction again? Sometimes we might get that confused. Let's go ahead and draw 4 cardinal points. North, south, east, and west. North is always on the top, okay? So this is your north, and you have your south, east, and west. Don't forget that. So if the barn is due north of the house, 200 yards, so this is 200 right here. And his tractor is 300 due east. So starting, it looks like the house is basically the reference point. So due east, you see going to the right, it's 300. So the question is, how many yards must he walk to go directly from his tractor to his barn if he walks in a straight line? So tractor to barn, let's call that X. Now this problem, you're provided with 3 sides. I call these SSS problems. SSS problems involving right triangles. Whenever you're dealing with SSS problems, when you're given 2 sides and you have to find the third side involving a right triangle, you have to make use of the Pythagorean theorem. Okay, so do not forget. Pythagorean theorem are used to solve SSS problems involving right triangles. If it's not right, then you have to use other formulas like the law of cosines and things like that. Okay, so we have identified the formula we're going to use. What on earth is the Pythagorean theorem? It tells us that a squared plus b squared equals c squared. Basically, the sum of the square of the legs is equal to the square of the hypotenuse, okay? So the legs are the 2 shorter sides, and the hypotenuse, C, is the longest side, the side opposite the 90-degree angle. So let's call this, how about we call this B, call this A, and then we call this C. We know that this is C because it's opposite 90 degrees. That is the biggest angle in the triangle. So the biggest angle in the triangle is opposite the longest side. So the C, A and B, it doesn't matter how you label these. I can call this A, B, or call this D, A. It doesn't really matter, they're both legs. But the hypotenuse matters. This is always C. If you get this wrong, then you get the problem incorrect, okay? So we have that, we want to solve for x. So let's go ahead and write down our Pythagorean theorem again. C squared equals A squared plus B squared. Now, if we apply this problem, this formula to this problem, what do we have? We have x squared, what we're looking for, equals a squared. A is 200, so we have 200 squared plus b squared, which is 300 squared. Okay? All right, now let's see. We want to solve for x, so let's simplify this. X squared, 200 squared is, you just square the 2. 2 times 2 is 4. And then 100, you have 2 zeros. If you square it, you're going to have 4 zeros, okay? So 4,000. 4000. Actually, it's not 4,000, it's 40,000. And then plus 300 squared, you square the 3, you get 9. And then 2 pairs of zeros is 4 pairs of zeros. 1, 2. I mean, 1 pair of 0 gives you 2 pairs of zeros. 0, 0. Okay? So what I did here is, if my work isn't clear, 200 squares. 200 times 200, right? All you do is multiply the numbers. 2 times 2, 4. And then you count all the zeros. 1, 2, 1, 2, 3, 4, 3, 4. It's just a basic trick. Anyway, 40,000. And then the same idea for 300 squared, 90,000. Okay, let's simplify that. I'm going to have x squared equals 13. 13, 0, 0, 0, 0, 130,000. Now to get x by itself, you take the square root of both sides, square root that, and then you have x is equal to the square root of 13, 130,000. Gotta be careful, there's zeros here. We don't want to lose anyone. Alright, so now that we have it set up, we're gonna have to simplify our answer. It looks like it's either going to be A or C because it has our root 13 there. All right, let's go ahead and simplify this. So to simplify this, we're going to have to break down 13,000. So let's see. The thing that we can use a shortcut here because of these 4 zeros. Whenever you see a lot of zeros, you know that 10 is a factor. Okay, so we have 13,000. Actually 130,000. If you want to break this down, we can take out a 10. If you take out a 10 from 130,000, you have 13,000. Let's take out another 10. What do you have? You have 1300, 1300. Take out another 10. You have, what do you have? 130. What do you see happening here? Anytime you factor out a 10, the number of zeros decrease by 1. Okay? Just as if you multiply by 10, the number of zeros increase by 1. There's still a 0 there, so let's take out another 10, and you're left with 13. Alright? This is a prime number. It cannot be decomposed any further. Now, the nice thing about this approach is that the 10s that repeat can be rooted. Alright? So these two 10s is 10 times 10. What is the square root of 10 times 10? The square root of 10 times 10 is 10. Repeated factors, when you root repeated factors, they just come out as 1 because the square root is basically the number that you multiply by itself to get the square. Okay? So 10 times 10 is 10 squared. If you root that, you get 10. And then 10 times 10 again. If you take the square root of that, you get 10. This 13 doesn't have any partner to be rooted with, identical roots, identical factor, so it stays behind. Okay? There are different ways that people explain this. Some people describe this as pairs of stockings. I mean, if you have two identical pairs, they count as 1, you know, however you view it. But 10 times 10 is 10 squared. You root that, you get 10. 10 times 10 is 10 squared. You root that, you get 10. Okay? So what does that mean? It means that the square root of 130,000 is going to be it's going to be 10, this first one that we factored out, times this second 10 that we factored out, root 13. What is 10 times 10? 100 root 13. Okay, so our final answer is 100 root 13 as the linear distance between the barn house and the tractor. That's how far the two are from each other. 100 root 13. And our answer is option letter C. Okay, so that's that. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to our channel for updates to the remainder of this review series. And also feel free to post a comment to let us know if you have any questions, clarifications, concerns, or if you want to give us feedback on how we can improve our tutorials. We really appreciate it. More clips can be found on mathgoodserve.com. Thanks again for watching and have a wonderful day.